All right, welcome everyone at my talk about microservices and Hypermedia APIs. I've got a lot to cover, so I'll get right to it. But first, who am I? Actually, I come from Belgium. I work for a consultancy company called Ordina. I love open source. I love to contribute a bit. And I run, I'm technical lead and coding architect at Proximus, which is the biggest telco organization in Belgium. And we've done actually what I will be talking about today. So let's take a look at microservices first. Who actually knows about microservices? Okay, quite a lot of people. Who actually uses microservices? All right, still a couple, that's nice. So it's actually quite a hype these days. There's many people here as well, so microservices, it attracts people because it's nice, it's cool, it's fancy. Right, but actually we have to look past that hype. It's very important. So, what are the benefits first? There are also some pitfalls, I'll get to that later, but first, benefits, they're small, easy to understand, code bases. That's very important because it decreases the risk of changes. So you feel more comfortable working on the code base. And how small, you could think of it like, James Lewis puts it this way, it should be as big as your head. Maybe in code, but that depends a bit on your syntax and the verbosity of your language. But just simply, you could look at it as, does the functionality fit in your head? Do you need multiple people to really understand what a microservice is doing? If you do, maybe it's too big. Next thing is it's easy to scale because they're smaller, they're independent, they're autonomous. They can be scaled up, and of course you have to build them stateless, so that's also easier to scale. Easier to throw away. Martin Fowler calls it sacrificial architecture, so you build something with the idea that you'll throw it away later. Right? This avoids legacy, which is pretty hard to replace. And with monoliths, you also have too many dependencies, and so small chunks it's much harder to replace. While if you have these microservices, they're independent, they're small, they're doing one specific thing, you can just throw them away and rewrite them in a couple of days, hopefully, if they're not too big. Then easy to deploy, of course, since they're so small and independent and autonomous. Ability to use different technology stack, so best tools for the job, right? That's very important. It's also what attracts people to it, I suppose, that you're not stuck with your initial choice of your monolith. But you can actually use any kind of language, any kind of framework in different microservices, which is really nice. I'm not saying you should be a cowboy about it and just do whatever you want, whenever you want, because then it's kind of hard to keep track of it, and also the handover to other people is getting more difficult. Then smaller teams, of course, like the 2-pizza team, allows you to actually deliver functionality faster, because you're more focused, and you can have more teams working on one huge application, which is consisting of multiple microservices at the same time, because they work independently. And of course, system resilience, if you build it in, if you architect for resilience. It's important for microservices that you think of it up front, but if you do take care of it well, then actually, if one part of the system goes down, it shouldn't impact your entire system. Right? So in a monolith, if you had one problem of leaking memory or whatever, it could drag your entire monolith down. And now it's different. Okay? So these are the benefits of microservices. They can be very nice to adopt, but the problem is often that people are not really good at building monoliths, and they're actually looking for microservices as the best solution to all their problems, which is definitely not going to be a better solution then. Like Simon Brown puts it, if you can't build a monolith, then what do you think is going to happen with your microservices? It's much more complex, actually. Your operational complexity goes way up, which actually, I will talk about now about the pitfalls. Right? Very important to know is that there's a couple things that if you don't get them right, then your microservices becomes really a ball of mud. And it's much harder to maintain, much harder for a simple developer as well to actually keep track of this huge complex microservice architecture. Okay, so first thing, failing to adopt the contract first design approach. Contracts are very important. And you should see it as like you're building in cities, and you're interested in the communication between those cities. For example, you want to route water or electricity to those cities, but you don't want to know the individual houses. You don't want to know what's going on there, because that's up to the microservice internally to take care of. It can be anything, this implementation. But what's important is that you actually make sure that your contracts are following a certain standard, some guidelines. That's the most important thing, actually, about designing this thing up front. Then assuming the wrong communication protocol, not saying there's one right communication protocol, there are multiple that you could be using, but you have to make sure that you use the right one for the right job. So you can actually have, for example, HTTP with REST on top of it, which I will be talking about a lot later. But you can also use event-driven things, which are sometimes much more useful in certain scenarios. So just think about it really well. Then, a best practice for monoliths is having this huge shared domain model, right? Which is kind of complex, kind of hard to understand. But with microservices, you don't want that. You don't want to have this model across microservices. You want bounded contexts from DDD. That's super important. You can't actually have a model which crosses microservices. You have to duplicate model, which is a trade-off, right? You don't like to duplicate code, but you have to do it in this way. So that's important to get right. And the service boundaries, of course, these bounded contexts, you have to think of them well. Because, for example, if you have a customer microservice, and then you have a customer accounts microservice, you could think of it as two different granularities. So that could be that bubble in a bubble effect, and then you actually have the problems of identifying where you should put new functionality. Okay, that's important. And then neglecting DevOps and testing concerns, super important, of course, because you want to automate everything. You want to make sure you work in product teams, that you can make changes and are actually confident that it's actually going to work. It's very important, especially with microservices, with monoliths. You might still get around that with integration tests, but with microservices, it's much harder because you have all these hops, these different floating components that could go down at any minute. So that's super important. The human factor, actually, microservices needs DevOps, and DevOps is partially a cultural change. So people need to talk to each other. You need to put people together, cross-functional teams, that kind of stuff. And of course, Ops is also a part of that. And they will definitely need to be involved in your microservices architecture because they need to make sure that this runs in production. Although, when you are working DevOps, your developers also share that responsibility. But you have to make sure that you have the right tools, you have the right processes to really get that complexity under control of operations. And then there's something else, this eventual consistency. Right? We are actually used to writing these transactions across systems, and with microservices, you don't really want to do that. You want to work with this eventual consistency, where it's not really at a certain point in time where you have a full consistent system, but you can rely on that it's eventually going to be consistent. And that's a concept that you have to embrace, really. Okay, so these are the pitfalls. And then let's take a look at what tools do we have from Netflix, for example, which can help us avoid some of these pitfalls and can help us manage these microservices. Okay, who's familiar with Netflix OSS? And a couple of hands already. So for those, this won't be that new, but for the others, there are some really nice tools that Netflix has built for us. They open source it, they continue to do so. And one of them is the gateway. They call it Zool. Zool from Ghostbusters. It's that gatekeeper monster. And it works a bit like this. So you've got a request coming in, then it goes through these pre-filters, which can handle do some logic on that request. It's being sent with the routing filters to the microservice, the origin server. When it comes back, it goes through post filters, where you can handle these responses and do some specific logic on that, and then you can return them to the client. And you have some custom filters and error filters. That's about it. So pretty simple, but this offers up a lot of functionalities and possibilities. So what's the use, really? Why would you be using this? First of all, surgical routing, which is really nice. If you have your boss, his phone is not working, you can say, okay, for his IP address or for his specific device, we're going to route him to a specific cluster which has much more debugging on or something like that. So that's possible. So what else? Stress testing, of course. You can actually use this system for that as well. Load testing, of course, as well. And canary testing. Who actually does canary testing? I don't think anyone is doing that, right? Yeah, but Netflix is doing that. And you can actually use Zool for that. So I made a little diagram to show you how that would work. You have requests coming into the gateway being forwarded to the microservices. Pretty simple, right? But what if you have this new functionality? You want to deploy this, and you want to see if it actually is working well under load in production, right? So you put up this new cluster with this new functionality, and you put this little canary bird on top of it, which is just this user who's going to access it. It could be one user, it could be multiple users. You make a change in the gateway, which is really easy to do. I'll get to that later. And then you send in this request, which could be like 1% of the customer base. You could increase this as well over time. And they will actually go to this new microservice or this new cluster. And so you can test this with these users. Then when you see that this microservice is not holding up, it's going down, then your canary bird dies, right? But that's like in the mines. You don't care about that one canary bird. It's just dispensable, right? And then you just make a change in your gateway again because you see, it's not holding up yet, so let's roll it back. Really easy to change. And then those requests will be forwarded to the original microservice as well. So that's kind of nice functionality, right? Especially for business as well. They like to have this kind of functionality. So aside from that, there's, of course, you can do with these post and pre-routers, a lot of other stuff like request authentication, authorization, choosing which origin to route to, routing, of course, obviously, logging information, adding headers, statistics, metrics, error handling, all that kind of stuff. It's really, you can do whatever. They're just filters, right? And there's an interesting one, which is dynamic behavior change. I don't know if you guys can see this because it's kind of low on the screen. But behavior change dynamically is pretty powerful, but also maybe pretty dangerous. You have to watch out. So you have these pre-filters, these routing filters, and these post filters, just like in the previous graph, right, or diagram. You get these requests coming in, responses going out, and you have a shared request context. So that's just what we saw already. But the next thing is this over here. That's pretty fancy stuff. So you've got a filter publisher and then a persistent store, which is in Netflix by default Cassandra. You can put filters by writing them and then putting them in the Cassandra store in the system by having this filter puller, right? It will put them in the system, will then be compiled, be checked if it's actually working, and then it will be injected dynamically into your different filter stacks. Which means that you don't have to do a deploy of anything. You just have your Zool running, your gateway, and operations can just write these filters or change these filters and inject them automatically. Okay, that's pretty powerful, but also pretty dangerous, like I said. If you have ops guys who don't really know what they're doing and they have to do this, then I wouldn't really give them that possibility. So that's a side mark. So something else that Netflix is doing, they've seen that we have all these calls coming into the gateway for a certain request flow, for a certain functional flow. And we see that for each device, they're a little different, and they always have these separate calls which have each their little part of network latency. Okay? And then we actually forward them to the microservice, and we actually get the response back, and we just respond that. Okay? So what they actually did was they saw that, and they actually thought, can't we limit this latency to just one call? But that would imply that you have to put all these calls just into one. But then, who's going to aggregate this? And actually, this gateway can do that. So the gateway has a possibility to have these adapters specific for each client and for each device, which will then send calls to all the backend services or the microservices, and will then just aggregate them back and return them to the device. Okay, this offers a couple of possibilities, a couple improvements, not just that you have your network optimization, but also that you have these specific aggregations per client and per device, which is often something you don't want to put directly in your microservice, because your microservice wants its own granularity, its own form of representing the data. Okay, but there's a big important thing to mention here. That's, you have to, like Netflix is doing that with this dynamic filter thing, right? So that means they don't have any process. They don't have a bottleneck team who has to change the gateway, who is the only guys responsible, who are the only guys responsible for changing this. I mean, the teams of the microservices are doing the changes, which is super important because otherwise you're creating this ESB. And an ESB in microservices is quite an anti-pattern because you want to have your pipes dumb, and that's a pipe, and your endpoints smart, and those are the microservices. Okay, so you have to watch out that you do this without any process and no bottlenecks. Okay, so that's what actually the gateway was. There's something else from Netflix called Eureka, and it's actually because it discovers things, it discovers microservices. So how does it actually work? You have this service registry called Eureka, which keeps track of microservices. They register into the Eureka registry. So even if you have 2 clones, then it will actually also register that. And then there are heartbeats being sent continuously. If my yeah, okay, heartbeats, right? And then what if one goes down? Then he will stop sending heartbeats, and it will actually get removed from the registry, obviously. And if another one goes down, then the full application gets removed. Okay, that's very straightforward. But it's also, Eureka offers this nice failover or this resiliency functionality. So you can have just one Eureka server, but it's actually recommended that you have at least 2 in every zone. So you can set up another one, and it will automatically call the other one, and it will duplicate the registry. So that makes it easier to have this complete failover. What if one goes down? Then your microservice will call the other one. Straightforward. What if that one goes down and you don't have any registry anymore? You could think, okay, none of your microservices will work anymore because you don't have a registry. You can't call other microservices anymore. However, Eureka has something in mind for that as well, which is client caching. They actually put the cached registry on every microservice, which is pretty neat, right? But of course, if one of the other microservices goes down, he won't know about it because that microservice won't actually inform him. Okay, that's the downside. But that's really in the worst case scenario. Okay, so there's another thing, Ribbon. Okay, just client-side load balancer that you can use, pretty straightforward, but it also talks to Eureka, which is nice. So it will not try to load balance over clones, over microservices that are not healthy or that are down actually. Okay, then there's another thing. There's a pattern called the bulkhead pattern. Anyone know the bulkhead pattern? No, I'm sure you guys use it. It's actually resource pools, like connection pools, thread pools, that kind of stuff. Everybody uses them, right? But it originates from the ships, which had these vertical walls to prevent on a hull breach that the whole ship would sink. It isolates the failure. And like in the Titanic, you had these doors, right, that they had to jump through. Right? That's actually what you have in your code, like everywhere, especially if you have an integration point. So aside from that, you have the circuit breaker. Circuit breaker is just there to protect your house from burning down when your laundry machine or something starts to malfunction. And that's, you should also actually implement in your integration endpoints. And that shouldn't just be for microservices, by the way. It's a very nice pattern to implement for any kind of integration that you have with any other system that could fail. Okay. So how that actually works is you have a microservice calling a backend or another microservice or whatever, and you have calls going through, requests and responses. Right? And you have this circuit breaker in the middle, which protects it. So your calls go through, and then what if your backend goes down or responds slowly or is just under very heavy load and doesn't respond in, let's say, 10 minutes? You could just wait But then your own system would fail as well, which is not what you want, right? You want to isolate that. So what could happen on the next request? It will actually call the backend. We'll come back with some information in the circuit breaker. It's not going right, okay? So we have to watch out. We have to set a threshold. If this occurs a lot, then the threshold will be reached, and on that occasion, the circuit will actually open, which is not a good thing. Open circuit means bad, and closed circuit means there's actually electricity going through, right? So the circuit goes open, and next calls will actually be failing fast, which means that you have fast response times. It wouldn't work anyway, so that's okay. But you wouldn't try to also call this backend continuously. Okay, that's very important because the backend might be under very heavy load, and if it gets healthy again, it might be bombarded with extra calls again, who actually were waiting, which is actually very bad because then he would go down again. So this way you protect the backend as well as yours. So you have this half open state where there will be just one request that can go through. When it comes back, it will check, is it already healthy or not, this backend? And in case it's not, it will open the circuit again. Will be failing fast again. Then what if your backend actually goes healthy again, or your microservice? Then the first couple of requests will fail again because of the system. But then there will be this half open state again, circuit will close again, and he will actually be informed that now the backend is working correctly. And it will just reset everything. Okay? And then everything is hunky-dory. Okay, so that's how it actually works behind the screen. So if you have something like this, gateway, and then a couple of microservices who can also talk to each other, then you should put them on all the integration points. And if you use Zool, it's already integrated, at least if you use Spring Cloud. I'm not entirely sure if it's also in Zool directly, but you can build it yourself otherwise. How this works internally is you have these commands. They can be proxies or just annotations if you use Spring Cloud. They can work for any type of request. They'll go through this flow. So it's actually checking if the circuit is open or not, and then it will check if the thread pool or the queue is full. And that's actually this bulkhead. It will actually have timeouts on requests, and it actually has a pool of requests. So that means that if you have slow connections, that you won't just keep adding threads or adding connections, which is pretty dangerous because your memory will just be consumed really quickly. It actually has these fallbacks as well, where you can return some sane values or go to another service which is healthy, or maybe also you can return a cached response, which might be useful from a business point of view, that the user or the client doesn't receive the most up-to-date information, but at least he receives some information, right? Okay, so that's how it internally works, and it also reports a lot. Okay, so it has a stream of information that comes out, which can then be displayed in a nice graph like this. If you're actually using Hystrix, you'll probably be very familiar with this. Hystrix is the name of the library, by the way. So this is a huge graph which shows you what's going on in real time with your system, with all the integration points. Okay, so it looks a bit like this in one of them. You have a ton of requests going through. You can see how many actually are going through right now per second. You can see how many were failing the last 10 seconds. You can see if the circuit is open or closed, or forced closed can also be possible. Also the 99 percentiles, which are important to tune your bulkhead or your resource pools. And then also what actually happens, thread timeouts, thread pool rejections, failures and exceptions. So this is interesting to see at real time what's going on and to be able to act directly. Okay, so if you look at this again, you can see that this one here is used a lot, that one on the top right as well, but here is 2% failures, so that's ordered first, because that needs your attention. Okay, you can use this is just completely open source, right? There's another thing, the 12-factor app, which is very important if you want to go to the cloud, actually has this thing with externalized configuration. And with microservices, this is also important. You don't want to actually change the configuration on all your microservices. You want to, have one central location where your configuration is versioned, and you can really nicely interact with that from the microservices. And Spring Cloud actually offers something, Spring Cloud config server, which is just does that. It goes to a Git server or an SVN server, or it could be even on the class path or on the file system even, whatever. And it gets the configuration from there, which can be Proti files, YAML files, whatever, and then exposes it through RESTful endpoints, which is pretty neat because it's also easy to debug that way. And then these microservices just call this config server, these RESTful endpoints, and retrieve the responses in JSON. And there's one more thing from Netflix, HATEOAS, which is just the library that Netflix uses to expose configuration, which is really easy to work with. And if you use Spring Cloud, then all this is integrated. All the configuration from Netflix is automatically available, which you can change really easily. Okay, so pretty useful. And then we have the Spring Boot admin panel, which is showing all your microservices in case you use Spring Boot. I don't know, is anyone already using Spring Boot? That's a lot, okay. Yeah, you have this actuator there, right, which is the dependency that you can use, which exposes lots of endpoints with metrics, environment variables, all that stuff. And this just shows it in a really nice way, and it's no hassle at all to set it up. And you can get nice information in a nice graphical way like this. Yeah, you can set log levels as well, which is pretty neat. You can even have a JMX editor. Okay, so those are some of the tools that we're using, and especially integrates very well with the Netflix stack. But there's a second part to this talk, which I want to get into. Actually, when you have all these microservices that are running, and you can manage them by using, for example, the Netflix stack, then that's covered. But there's one more very important thing of the pitfalls that I mentioned first, the contracts. You have to make sure that your contracts are well defined and that your microservices are loosely coupled. And that's what we can do with Hypermedia. So there's this very expensive word, HATEOAS or HATEOAS. Does anyone know this word? Okay, that's great. Does anyone know how to officially pronounce it? Nobody knows, right? You can maybe say like Cheerios, HATEOAS, or HATEOAS, or whatever. We can just call it Hypermedia as well. And this is actually based on, this is actually a subconstraint of REST itself, which is not used very much, right? So if you look at the constraints of REST, you've got client server, stateless, you have to use caching, uniform interface, layer system, and code on demand. So those are the most the constraints, but they're also subconstraints. And for uniform interface, which is arguably the most important one, you have identification of resources, you have manipulation via representations, self-descriptive messages, and Hypermedia as the engine of application state. Okay, so what if you use HTTP? You get all this stuff for free. Okay, you don't have to do anything. That's just in HTTP. Okay, you can also use, by the way, REST with something else, another protocol, but I've never seen it before. So, so for these identification of resources, you got URIs. For manipulation via representations, that's basically just the response bodies and the request bodies. And then these self-descriptive messages are headers. Okay, so that's all in the HTTP spec. But what's not there is the Hypermedia as the engine of application state. You actually have to do something for that. So actually, if you don't do that, then you don't adhere to the uniform interface principle or constraint. And then you are missing out on two of them, of two of the three advantages. And those are pretty important. It's independent evolution and decoupled implementation. Okay, and it turns out this is actually what we actually want to achieve in microservices. We want to independently evolve our microservices, and we want to be decoupled from other microservices. Okay, that's pretty important. So why would you go for HATEOAS or Hypermedia? Lots of text, actually. If you are working on a server, you change something, and you actually notice all your clients are breaking. Okay? That could be solved by Hypermedia, partially at least. We at Proximus, we actually did, we changed our name recently. It was first Belgacom, and now it's Proximus. And we saw that everything broke, because everything had hard-coded bookmarks for Belgacom. So we had to change everything, everywhere. Okay, you don't want to do that, right? And then there's a thing if you change your server and you see that your clients are breaking, that it could actually be that they don't break and they just continue to execute their own code, right? Which is wrong as opposed to what's on the server running. So that's very dangerous. So all these things can be solved by Hypermedia, or at least a part of it. So let's take a look at Hypermedia in action. Right? We have Amazon websites. So what if you go to the index, you see all these links, right? What if we want to, it's hard to read, right? What if we want to go to fine art? You can click that link, you see it, and you can click it. What if you want to go, it's really badly positioned, but what if you want to go to oil paint or paintings? You can click on paintings there. You see all paintings, you can click on it, right? And then you see this nerd in the basement picture, this painting, which I really want to buy. Right? So you can actually read the title of it, and you can click it, and you can see the resource. Okay, so that's what we want to have, right? Nerd in the basement. So actually, if I were to explain to you how to navigate to, or actually how to obtain this painting, what would I be telling you? Would I be telling you that you have to go to Amazon.com, then just go to paintings, all paintings, and then just check the nerd in the basement one? That's one way of saying it, but you can also say, like, just open your browser and type, yeah, this thing, right? It's not very friendly URL, but you have to write it. Just type it, you know. Well, who is in favor of option 1? Who is in favor of option 2? Okay, even less, that's good. All the other ones don't have an opinion, I suppose. Actually, it allows you to, if you use HTML, which we saw in action, then you actually have Hypermedia by default. You have these tags, A and form tags, which actually are a link to another page or another resource. And form is even doing some specific operation on it, except for get. Actually, the browser is intelligent enough to read the syntax and understand that it has to show a link for that. Okay, so that's out of the box. So if you're building this in your API, then it's important that you know 3 things, right? Where do you have to start, right? Where do you have to go first? It's going to the index, right? And that could be an index resource on your API. In websites, it's often just the home page, okay? Where am I currently? So this resource that I'm actually reading, what is it actually? How can I interpret it? And also, if you look at that from a website perspective, then it's just the browser who needs to interpret this HTML, which he does all the time. So that's not a problem. And where can I go? And those are the links. So a web page always shows links anyway, but your resource can also expose links. And those are then specific tags that you put into your representation. Okay, so question here is, like Amazon.com and any other website in the whole wide world actually uses HATEOAS or Hypermedia. They have these links, they have these forms. Then why doesn't your API do that? The key point here is that the World Wide Web was able to grow that big because it uses Hypermedia. It uses these links, because if you have to bookmark everything, you wouldn't be able to work with the World Wide Web at all, because things were actually breaking all the time. Right? Links change all the time. So it's very important also to see the benefit of this and to understand that it can also aid you in your own API. So let's take a look at the runtime action discovery from XML. You can do that in JSON as well. So you have, let's say, a bank account, and you get a resource to that, and you have $100 on it, and you get some links back in the response. How you will implement this in your API, you can use text HTML, like we saw with the Amazon website, or you could use JSON. JSON is more useful because if you work with JavaScript clients, it's just by default a perfect fit. But if you work with microservices, there's also a lot of support in languages for JSON and XML, so you can just choose. But what if you want to use JSON specifically? So there's a lot more. You actually have to put something on top of it, because JSON is not a Hypermedia format. Okay, HTML is, sorry, because it has these A tags and these form tags. So what you have to do in JSON, you have to add that on top of the syntax, which is just It doesn't have any tags there. So you can use JSON-LD, HAL, collection-LD, Siren. There are a couple more. There's no real consensus in the community yet about which one is the best one to use. They all have their pros and cons. For example, with HAL, which is the one we chose, you don't have support for operations. So you can't communicate to the client which operations he can do on that resource. So for example, you can't tell him you can use a post or a get on this one. It's just up to the client to have that out-of-bound information. Okay, so we chose HAL. Why? Because it's really nicely integrating with Spring. Spring has built this library called Spring HATEOAS or HATEOAS, and that's just making it so much easier to actually do that on the client, on the server side. If you want to do that on the client, there's also tons of libraries for that. I mean, if you want to do that in JavaScript. So that's the format. So some considerations for Hypermedia. It's maturity. So it's not really something which is commonly used yet. There are big companies already using it, like Google, for example. But it's not something which is super common. So you have to be aware that it's still growing, it's in maturity, and you might have some growing pains there. Okay, so just make sure you investigate it well, and then adopt it with the right mindset, with these concerns that I mentioned as well in mind. The client implementation is often the difficult part, not the server, and because the client has to do this conditional check, whether he gets a relation back or not, whether he gets that link back or not. And if he gets that link back, then for example for the bank account, he shows a deposit or a withdraw button or not. So that's a conditional. So his framework actually has to cope with that extra complexity. Okay, so that's something very important. Also on the client, if you work with JavaScript, you have to really think about caching, because every time you make you go from resource to resource, you make a hop. Okay, so that's extra latency. And if you cache, you can get around that. So caching is super important, and versioning. Of course, you can use things like content negotiation to do versioning, which is actually, in my opinion, the best way to do it, but you can also put it in the URI. So it's really important to keep that in mind also when you implement your client and your server, to use certain tools. And I think it's Jackson that has this JSON view annotation, which is pretty neat, because then you can version on property level of your POJOs. So you don't have to make a whole duplication of your model to make new versions. You can really do fine-grained versioning. Okay, definitely look into that if you have this specific need. So documentation, one more thing, important in microservices. If you don't document it, then people won't know what's actually out there, which functionalities are there, and where they can get them. Okay, so normally this is a bit faster. She's a bit tired today, I think. So there's actually very important to realize what you should document. Okay, it should be resources, and of course, like request responses, how you can call them, what you can expect from the response, that kind of stuff you have to document. Links, how you can go from one resource to another, and how and what kind of traversing you have. That's very important. And cross-cutting concerns like headers that are common, that kind of stuff. So you have to document all this to have a comprehensive understanding on the clients how they must consume your microservice, or your contract of your microservice at least. Okay, so this is what you should document. What you shouldn't document is URIs. Okay, that's one thing you shouldn't document, because then people start bookmarking your URIs in their clients or in their other microservices. And then if you change your URIs, you might have super complex or super nice implementation of Hypermedia in your server. As long as people bookmark these URIs on the client, it's actually gonna break. So there's no point then in all that effort. So you have to have it on both sides. Okay, so don't bookmark those URIs and don't document them. Okay, so what does it look like when you get it wrong? It looks like this, because you got all these URIs. And what does it look like when you get it right? The GitHub API, that's a nice example of a Hypermedia API, which is nicely documented. So Swagger, which I showed in the first screenshot, actually it shows not to support Hypermedia. I mean, it's still a nice library, but it would be too hard, I suppose, for the developers to get that Hypermedia concern in there. It wasn't designed for that, and if you're okay with that, then fine. Swagger is definitely a good tool, but if you want this Hypermedia documented, then you're not going to be doing that with Swagger because they just don't support it. So also Swagger is URI-centric, so it starts with these URIs, and you can get information for these URIs. So that's not what we want to do, and it's pretty leaky. It actually tries to understand the implementation, and it tries to get actually the documentation deducted from that implementation. And that actually might sometimes not work out well. Like for example, you have this response entity, and you have these status codes, headers, and body. But that's all part of the body of the response entity, which is not correct. I mean, headers are not part of the body. So it's just, sometimes it fails at deducting this information because it's really hard to do that. You have all these filters in between your annotations that you put on your production code, and there might be happening tons of stuff that actually impact this. Okay, and it's also giving you sometimes a lot of information which is not accurate. For example, these status codes are not always returned from the service, so it's just wrong. Okay, so that's the downside of using Swagger in that perspective. So that's another thing, and also it's quite big. So if you look at Spring Boot, Tomcat, and Hibernate together, you have 25 megabytes. Swagger 31 megabytes. Although I have to say that since August, I think they've removed the Scala library from Swagger, so that might be smaller, but still it's a pretty big library. Okay, so best practices. Okay, if you want to write Hypermedia APIs documentations, or not just Hypermedia, but just in general as well, then you should be writing that in a format which is designed for writing, such as Markdown or ASCII doc. And you should not be using the implementation to deduct your documentation, especially not if it's through tons of annotations that sometimes are bigger than the code itself, the production code, because that's leaky, and that's actually it's a strategy which doesn't really work. And then you have to provide some guarantees that the documentation is up to date and accurate. That's super important because, of course, what's the point of having documentation if the documentation is not up to date? People are not going to trust it, and they are not going to read it. So it's better not to write any documentation at all then. So you have to have some guarantees, okay? Okay, there's one more slide actually. Oh, whoops. Hold on. Okay, so actually there's this library called REST-docs, which is just released like I think a couple weeks ago. REST-docs, which is from Spring, but it's not necessarily coupled to Spring. So it allows you to write your integration tests just like you normally do, and then based on these integration tests, if you use, for example, mock MVC, then you can actually add something to it and put some documentation on that, which means that if your integration test runs, it will generate these requests and responses, of course, like it normally does, but then it will also generate documentation out of that, which in the form of snippets, which are then, for example, request snippets and response snippets, or link snippets. And those things are super important for a client developer to have these samples. And it's really easy to just include them in, let's say, a HAL browser, if you're familiar with that, to just show you what's possible in requests and responses. Okay, so if I get actually my slides back up. Okay. Yeah, so this is the link to Spring REST docs. You definitely have to check it out. It's an awesome tool, and tomorrow I'll have another talk. I'll go more in detail about this. Spring REST docs is really very useful because it will, if you change, for example, your resource, your POJO, and you add an extra field in it, or you remove something, or you rename something, then, and you don't put that in your documentation part, in your test, then your test will fail. And you won't be able to build even, which is pretty neat. I mean, you don't want to ship any documentation which is not 100% accurate or up to date. Okay, so that's the tool, and I think it's really awesome. Okay, so that's my time, I think. I still have some time for questions, I suppose. If you want to ask something during the conference, I'm here tomorrow as well. So just come to me and we can chat about anything. Okay, thanks.